Hi everybody! So in about the 17th or 18th century, presumably because they were sick of repairing clocks, clockmakers in Switzerland invented a drive. What they came up with was this, and it's commonly called the Geneva drive. What it does is it allows this rotation to go into this rotation, which doesn't seem like a big deal, but when it rotates, it will only rotate this one step. The wheel here locks into that second wheel, stopping it moving any further, and it can only move when that peg moves it. It's actually quite hypnotic. Clockmakers used that ability of locking in place because it wasn't part of the drivetrain, it was just attached to the mainspring and prevented you overwinding it. But that ability to move, lock in place, wait, move again, became really important with the invention of cinema. A film works because we shine a light through a still image, then we cover it up, move that image and shine the light again, and as long as those images are in sequence and all this happens faster than 24 times a second, we see movement. That sequence of move it, hold it, move it, all accurately is ideal for a Geneva drive, and that's what you find in a projector. You see that there are teeth on a wheeled sprocket that's driven by the Geneva drive, and there's a shuttle that passes across the film to blank out the image for all of those steps to happen. It was first used in 1896 in the projectors of Oscar Mester, and it beat the pants off what Edison was using in his Vitascope, which was an egg beater mechanism that had been invented in 1893 by Georges Demene. Now, ordinary gears won't do that job because in order to turn, a gear needs a little gap. Without that gap, it'll lock together, but with that gap, it gets a little bit of wobble. It's a trade-off, it's called backlash, and that backlash over a long period of time can introduce inaccuracy. A Geneva drive doesn't do that, which is why they're used for things like counting banknotes. Now, of course, these come in different forms. This one's called an external drive, but you can get an internal version and you can get a spherical version. And for what it's worth, this is the common version, which has also led to the name as Maltese drive because this looks like a Maltese cross. But having four is really just a choice. It means that you get a 90-degree turn, but you don't have to have four. You can have as many of these little slots as you want, really, or you can fit within reason, and it's quite possible to do them with 10. So if I have 10 of those with my drive, then of course every time that does one turn, it's going to progress this by 1/10 or 36 degrees, and it's going to continue to do that as I turn this. And of course this is the heart of the drive, but there's nothing stopping you sticking bits on it. So if I take this and add a drum of numbers like that and a bearing in the middle, then I can put that on a bar and drive that to pass those numbers past a marker to create me a counter. To do that, of course, what I need is a drive wheel, and like I say, there's nothing to stop me putting something on that drive wheel, and in this case I've put a cog. So if I put that cog there like that, then that cog can be used to drive another one, another number drum with a cog on the bottom of it. And so I can put that there and use that to drive this, or more useful, use this to drive that, because as I drive this with my Geneva drive, it will drive the cog, which will have another Geneva drive attached to it, which will then step that through by 10. So we've got two drums with numbers on them, so we can count with it. We can count to 99, and of course I can keep on doing that. So I've printed off 4 of these number drums. 3 of them have the Geneva mechanism on one side and a cog on the other. The last one only has the Geneva mechanism because I'm only going to put 4 on, which means I can count to more or less 10,000, actually 9,999. So that's going to be the end cog, and I've got 4 of these with the Geneva drive and a corresponding cog, because those cogs are at 1-to-1 ratio. So 1 turn of that will give me 1 turn of this, and I need to stack those up. Now the first one is the drive cog, which goes on, and then we put a Geneva cog on to make sure that it links in. There we go. Then if we drive that cog, we'll drive that number drum. As we stack the number drums up, driving that cog will drive the whole lot. So if I drive that from a motor, I'll be able to count the number of times that motor turns. So we just keep on stacking them up with the cog to the cog and the Geneva to the Geneva drive, and we make sure that those numbers are all in line as we build it up with the 4. The end of the 4, this other plate goes on, and that's our counter. And that's it all together, making sure that I've lined up all the pegs and all the numbers with the cogs, otherwise it's all a bit squiffy. Now if I turn this, what will happen is it will engage there and obviously turn the number wheel, counting down, turning it that way, counting it up, turning it that way. So now it will count for me. Now there are lots of ways of making counters, but a Geneva wheel counter is a bit of fun to do, and these are the ones that are used for banknotes. Now as we keep turning that, of course, what we get is one full turn of this and 1/10 of a turn of that. Now because that's linked to that, that will turn 1/10. So when I've turned this 10 times, that will make one turn, which will move that digit by 1, and so on along the cascade. In order to read the numbers, we need a little window somewhere where we want those numbers to be, and we'll be able to read them as numbers on a dial, incrementing as we turn this. So what we've made for ourselves is a turn counter. So we can put a motor on here to drive this, and that motor could also drive something like a coil winder, and it would count the number of turns you put on your coil. Anyway, I hope you enjoyed the video. I will put this on Thingiverse. There are still things to do with it. Obviously, this is just to demonstrate the Geneva drive and the mechanism. There are things to do with it, including putting the window on, putting it on a stand, and of course we need to interface it to some way that attaches to a motor and attaches to our coil winder. But I hope you enjoyed the video. Thank you very much for watching, and please do remember to like and subscribe.